Hi all, good morning. Let's start Maths, Grade 11, Chapter 3. Chapter name is Trigonometric Functions, Subtopic Angles. Learning Objectives. After this session, learners will be able to convert angle from degree measures to radian measure, solve problems based on degrees and radians. Introduction. The word trigonometry is derived from the Greek words trigon and metron, and it means measuring of the sides of a triangle. Aryabhata's significant contribution to trigonometry include introducing the concept of sine, developing trigonometric tables, and provide accurate approximations for trigonometric values. The subject was originally developed to solve geometric problems involving triangles. It was studied by sea captains for navigation, surveyor to map out the new lands by engineers and the others. Currently, trigonometry is used in many areas such as the science and seismology, designing the electric circuits, describing the state of an atom, predicting the heights of tides in the ocean, analyzing a musical tone, and in many other areas. Angles. Angle is measure of rotation of a given ray about its initial point. The original ray is called the initial side and the final position of the ray after this rotation is called the terminal side of this angle. For example, here this one OA is its initial side and OB is its terminal side. Here this is this angle of measurement and O is this we call it a vertex. This is a positive angle because this is anti-clockwise. This is always positive. Let us see negative angle. See here this one, this OA is its initial side. If we observe, OB is below this initial side, that is a terminal side. So O is a vertex. So this is this negative angle. Measurement of angles. One is a degree measurement and the second one is a radians measure. Measurement of angles, let us still learn about this conversion also, degree measure. If a rotation from the initial side to the terminal side is 1 by 3/60th of a revolution. So the angle is said to have measure of 1 degree is written as 1 by degree. So a degree is divided into 36 minutes and a minute is divided into 60 seconds. 1/60th of a degree is called a minute, written as 1 here dash with single dash here. The 1/60th of this minute is called as a second. So we'll note it with a double dash for this seconds. For example, here OA from A to B we are coming to again to the same point. So this is an example for the 360 degrees. So it's something but an angle at a point. If we'll take any point here, entire this total angle will be 360 degrees. Next, angle on a straight line is 180 degrees. AB is a straight line, O is this point on the line. Then this angle is this 180 degrees. Angle from this here, A we are coming this anti-clockwise and will make rotation more than 180. So 180 plus 90 here. If we extend this line this is 180 and this angle is 90. So 180 plus 90 is 270 degrees. Therefore AOB is 270 degrees. And here this angle is 420 because first one rotation we have completed. This is 360. Again here this 60 degrees. So 360 plus 60 is 420 degrees. Similarly, when we go towards the clockwise direction, this is a negative, that is minus 30. The next one is minus 420. Radian measure. There is another unit of the measurement of an angle called as a radian measure. Angle subtended at the center by an arc of length 1 unit in a unit circle. Unit circle is a circle with the radius 1 unit is said to have a measure of 1 radian. For example, here this is the picture. If the radius is 1 unit and this one is this one and the arc is 1, then this angle is 1 radian. So angle AOB is 1 radian. Similarly here angle AOB is minus 1 radians. Here AOB is 1.5 radian. This is minus 1.5. The circumference of a circle of radius 1 unit is 2 pi. Relation between degree and radian. Since a circle is obtained at the center of an angle whose radian measures is 2 pi and degree measures is 360 degrees. We observe here a circle here. Then the angle at this point is 360 degrees. Measures of the radius, this is 2 pi. So 2 pi is equals to here 360 degrees. So 2 pi radians is equals to 360 degrees, or we can make it as a pi radian is equals to 180 degrees. Therefore 1 radian is equals to 180 divided by pi degrees, or 57 degrees and 60 minutes approximately. And 1 radian is equals to pi by 180 radian, that is 0.01746 radian approximately. The relation between degree measure and radian measure of some common angles are given in this below table. For example, degree 30 degrees is pi by 60 radians, 45 degrees is pi by 4, 60 degrees is pi by 3, 90 degrees is pi by 2, 180 degrees is pi, 270 degrees is 3 pi by 2, 360 degrees is equals to 2 pi. Exercise 3.1, first question. Find the radian measure corresponding to the following degrees: 25 degrees, minus 47 degrees 30 minutes, 240 degrees and 520 degrees. Solution. We know that 1 degree is equals to pi by 180 radian. Therefore, 28 degrees can be written as 28 into pi by 180 radians here. So, here 5 5 is 5 3 is 5 6 is. So, 5 pi by 36 radians. Therefore, 25 degrees is equals to pi divided by 36 radians. Second one, minus 47 degrees and 30 minutes. That is, let us convert the minutes into degrees. So, minus 47 is 30 minutes can be 30 by 60 degrees. That is half degree. So, 47 and half, that is nothing but minus 95 by 2 degrees. So, now let us convert into this one radians. So, minus 95 by 2 into pi by 180 radians. Then, let us cancel here 5 with this 5 1s, 5 9s, 5 3s, 5 6s. Therefore, we will get as 19 pi by 72 radians. The value here is negative. Third one, 240 degrees. 240 degrees is 240 divided into pi by 180 radians. 6 4s, 6 3s are here. So, 60 into 4 is 240, 60 into 3 is 180. Therefore, it will come as a 4 pi by 3 radians or 4 by 3 pi radians. Similarly, 520 degrees. 520 degrees can be written as 520 into pi by 180 radians. That is 26 pi by 9 radians. Let us see question number 2. Find the degree measure corresponding to the following radians. Use pi is 22 by 7. Solution. We know that 1 radian is equals to 180 by pi degrees. Therefore, 11 by 16 can be written as 11 by 16 radian is equals to 11 by 16 radians is equals to 11 by 16 into 180 by pi. That is 11 by 16 into 180 by pi can be written as 22 by 7. So 22 by 7 degrees. 11 1s, 11 2s. So then again 4 4s, 4 45s. We are going to get as 315 by 8 degrees. Now we know that this can be again make it as a 39 degrees plus 3 by 8 degrees. 3 by 8 degrees, let us convert into minutes into 60. So then we are going to get 22 minutes plus half minute. Half minute again let us convert into seconds into 60. So therefore 39 degrees, 22 minutes and 30 seconds. Let us see second one, minus 4 radians. So minus 4 radians can be written as a minus 4 into 180 by pi degrees. That is minus 4 into 180 by 22 into 7 degrees. 2 11s, 2 2s. So minus 2 by 11 into 180 into 7. If you multiply the numerator, we are going to get 2520 degrees divided by 11. So therefore, this is minus 229 degrees plus 1 by 11 degrees. Now let us convert this degrees into minutes, that is into 60. 60 by 11 can be written as again 5 plus again remaining the 5 value, let us convert into 60 seconds. Therefore, minus 229 plus 5 degrees plus 5 into 60 by 11 seconds. That is approximately here minus 229 degrees, 5 minutes and 27 seconds. Let us see third question. 5 pi by 3 radians. We know that 5 pi by 3 can be written as 5 pi by 3 into 180 by pi degrees in terms of degrees. Let us cancel pi and pi. Then we are going to get 5 by 3 into 180 by 1 degree. That is nothing but 300 degrees. Let us see fourth one. 7 pi by 6 radians. That is 7 pi by 6 is equals to 7 pi by 6 into 180 by pi degrees. Let us cancel pi and pi. 6 1 is 6 30 is. Then 30 into 7 is 210 degrees. Let us see question number 3. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Solution. Given that a wheel makes 360 revolutions in 1 minute, so number of revolutions in 60 seconds is 360 because 1 minute is equals to 60 seconds. So this is same sentence. In 60 seconds it will make 360 revolution. Therefore, number of revolution in 1 second is equals to 360 by 60, that is 6 revolutions. Now, angle made in one revolution is 360 degrees because we know that angle at one point is 360 degrees. So, therefore, radians made in one revolution is equals to 2 pi because we are converting this degrees into this radians. So, 360 is 2 pi. So, for the one revolution, this angle in radians is 2 pi radians. Therefore, radians made in 6 into 2 pi, that is 12 pi. Therefore, as per the question, through how many radians does it turn in 1 second? So, in 1 second, it will make this 12 pi radians. Exercise 3.1, question number 4. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeters by an arc of length 22 centimeters. Solution. Here, given radius is 100 centimeters, then length of arc is equals to 22 centimeters. So, now let us depict in the pictorial form here. Let us make a circle with this just radius of the 100 centimeters and let us keep this as an arc of 22 centimeters. Now, the angle, let us assume as a theta. Okay. Now, theta we can written as 22 by 100 radians because total angle, this one is this, in terms of this radians is 2 pi radians. So, this is nothing but this arc divided by radius. That is, arc length is 22 centimeters and the radius is 100 centimeters. Therefore, theta is equals to 22 by 100. Let us convert this theta into degrees. Is equals to into 22 by 100 into 180 by pi degrees. Now, instead of the pi, let us substitute 22 by 7 as per this problem here. The last asking us to use 22 by 7. So, substitute pi as is 22 by 7. So, 22 by 7. The 7 comes again to the numerator. Now, let us cancel 22 and 22. 0 and 0. Then, we are going to get theta as 63 by 5 degrees. This we can convert as again into this degrees and minutes. 5 1s are 5 2s are again 3 will be there. So 3 into 60 seconds here, 60 by this one. So that is 12 degrees. 3 into 60 divided by 5. 5 1s are 5 12s are. 12 into 3 is 36. So 12 degrees plus 36 minutes. We can write as this one is 12 degrees 36 minutes. Therefore, degree measure of the angle subtended at the center of the circle is 12 degrees 36 minutes. Exercise 3.1, question number 5. In a circle of diameter 40 centimeters. Here, diameter 40 centimeter means we should ensure that one radius is 20 centimeters. The length of the card is 20 centimeters. Find the length of minor arc of the card. So, in a circle there will be every time one is a minor arc, other one is a major arc. Given diameter of circle is 40 centimeters and the length of the card is 20 centimeters. So let us here make this measurements here. Then the diameter of the circle is 40 centimeters. So we can make this one, radius is equal to 20 centimeters. This angle of this AOB is theta. Then we are assuming this AB as a card of length 20 centimeters. Therefore, so here OA is equals to OB is equal to AB, because as the diameter is 40, this implies radius is 20 centimeters. Here OB is the radius and OA is also radius. So this is 20 centimeters, this is 20 centimeters, and it's clearly given card length is 20 centimeters. So AB is 20 centimeters. If we observe triangle OA, we know all sides are equal. When all sides are equal, we call the triangle as an equilateral triangle. This implies each angle in this triangle inside there is 30 degrees. That is nothing but theta is equals to 60 degrees. Therefore, theta is equals to 60 degrees, that is pi by 3 radians. Now we know that theta is equals to L by R. So pi by 3 is equals to, let L be this length of the minor arc and radius is 20. Next, cross multiplying, we are going to get L as 20 pi by 3. Therefore, the length of the minor arc of the card is equals to 20 pi by 3 centimeters. Therefore, length of minor arc is equals to 20 pi by 3 centimeters. Let us see question number 6. If in two circles, arcs of same length subtend angle 60 degrees and 75 degrees at the center, find the ratio of their radii. Solution. Let L1 and L2 be the length of the arc two circles and R1, R2 be the radii of a circle. Here, for the first circle, R1 is a radius. For the second circle, R2 is a radius. It's clearly given that L1 is equal to L2 because arc lengths are same. And but for the first circle, it subtends 60 degrees. And the second circle, it subtends 75 degrees. Now, we know that theta is equal to L by R. So, in the first circle, L1 by R1 is equal to 60. That is, L1 is equal to 60 into R1. The second circle, 75 degrees is equal to L2 by R2. That is, L2 is equal to 75 R2. Now, from 1 and 2, we can ensure that as L1 is equal to L2, 60 R1 is equal to 75 R2. Therefore, R1 by R2 is equal to, by transposing here this R2 to this left side and 60 to this right side, we are going to get R1 by R2 is equal to 75 by 60, that is 5 by 4. Therefore, ratio of radii is equal to 5:4. Let us see question number 7. Find the angle in radian through which a pendulum swings if its length is 75 centimeters and tip describes an arc of length 10 centimeters, 15 centimeters and 21 centimeters. Solution. Given length of the pendulum, if we make any example, if any pendulum is there, if its length is some r, okay, then this with nothing but this radius is also 75 centimeters, because this is how this pendulum rotates. And we know that theta is equal to L by R. Therefore, 10 centimeters is nothing but length of arc is equal to 10 centimeters. Therefore, theta is equal to R by L by R, that is 10 divided by 75. 10, 5 we can make it as a 5 2 ja, 5 15 ja, that is 2 by 15 radius. Second one, 15 centimeters. Now here length of this arc is 15 centimeters. Theta can be written as L by R, that is 15 divided by R, that is 15 by 75, that is 1 divided by 5 radians. Next one is 21 centimeters. Here arc is of length 21 centimeters. Therefore, theta is equals to arc divided by radial divided by r, that is 7 divided by 25, because 3 7s are 21, 3 25s are here. Therefore 7 by 25 radians. Thank you.